Hello everyone. In this video we'll learn the extreme value theorem. So if I have a function f that is continuous over an interval from a to bn, it's a closed interval. Then within this interval the function will have a minimum and maximum points, or we call them extreme values. Now when we talk about extreme values, we are talking about something called local maximum, local minimum, or absolute maximum, absolute minimum. In order to study whether we have an absolute minimum or maximum, we need to look at something called critical points. And a critical point is basically points on the graph in which the derivative, the first derivative, is 0. So that's the slope of the tangent is 0, or it does not exist. That's when you have asymptote, or maybe when you have a cusp, like sharp edge here, like that one, or any of these. So now at these critical points the function tends to change its direction. So let's look at this graph here. By looking at this point here, here, and also my endpoints, which is the beginning and the end of the graph, we will notice something. That this point is basically the highest point in the graph. So we call it an absolute maximum point. Now if you look at this point here, it is also a maximum point, but it's lower than this point, so we'll call it local maximum. Now at these 2 points we notice something. The slope at this point is 0, and the slope here does not exist. So the slope is 0, the slope does not exist. These are critical points. Both of them are maximum point, but one of them is local, one of them is absolute. Now there is something else about being a maximum point, in which if I try to see the behavior of the function before this point, I will notice that the function was growing, so it's increasing. And when the function is increasing from left to right, the slope will be positive. And when you touch this point, and the slope became 0, and then it goes down again, and the slope is negative. So what happened basically? It was changing from positive, and then 0 at this point, and then negative, or maybe does not exist here. So that's a maximum point. So the function was growing and then goes down. Where if you talk about the points, this one and this one, we notice that this one is lower, this point is lower, this one, so this is an absolute minimum. And in this point, the slope is 0. The slope is 0 here, so it's a local minimum point. Let's move on to the next question and try to find out whether the points are max, minimum, absolute, or local, or maybe none of these. So first of all, let's take the endpoints. I notice that the function is growing from both sides. So what does that mean? There is no extreme value here. Same with this point here, no extreme value. Now let's see this point here and this point here. The function is discontinuous, not continuous, and it's undefined here. So I cannot consider this an extreme value. So it's not extreme value. But what about this one? Well, this one is a point, if I consider this shape only, that's considered as a minimum point, so local minimum. Now, moving on to the point here, which is this one here. The slope here is 0. The function was increasing, so the slope is positive, and then decrease, it's negative. So this is a maximum point. Now, is it absolute maximum? Yes, because it is the highest point in the whole graph. Moving into this point here. This is called an inflection point. What happened at this point? Although the slope, the first derivative the slope is 0, but what happened? The slope before that was tend to go down, so it's negative, and it continued down. So there is no change on the direction. Although it's a critical point, there's no change in the direction. So this is not an extreme value, not an extreme value. For all inflection points, they are critical points, but they are not extreme values. It's not maximum or minimum points. So now let's move to this point here. Well, this seems to be a minimum point, and it's a sharp like cusp, so it's a local minima. The derivative does not exist here. And same with this one. The derivative does not exist. And it is, the function was growing, so the derivative was positive before, and it turns to be negative later on, after. So it's local maximum. And here we go. Let's move to the next. Here we have some steps we need to do in order to find an extreme values for any function. So first of all, we need to know that we are doing it in a closed interval AB. Now we need to find the critical points. That's our first task. And to find the critical point in an open interval, we need to find the derivative, the first derivative of this function, and make it equal to 0. So we'll find f prime and make it equal to 0. So we need to find these critical points. Then next step, we will evaluate the function at these critical points. And next we will evaluate the endpoints. Then we will find the value or the slope for points between the critical points to see whether the function was going up and then goes down, or maybe it was down and then goes up. So we need to tell whether this is maximum or a minimum point. The least values will be the minimum, the greatest values will be maximum. So in this question, we need to find the extreme values, and we will follow the same steps. So first step, you need to find the derivative, and that's equal to 4x cubed minus 4x. Then make it equal to 0 and solve for x. Make sure that these points belongs to this interval. So 0 is within the interval, 1 is within the interval, and -1 within the interval. So these points are critical points. We need to find now the value of the function at these points and at the endpoints. So we're going to go here and say, what is f? -2 first, f the -1 a critical point, if the 0 is a critical point, f1 and f2 endpoints. So these two are endpoints and the rest are critical points. By substituting in the function, so -2 to the power of 4 minus 2 times -2 to the power of 2. Same here, -1, 4. And 2 to the power of 4 minus 2 times 2 squared. Now here will be 8. That's -1, 0, -1, and 8. We need these points to draw our number line and study the sign. So I'm just going to list the points here. So f -2 is 8, f -1 is -1, f0 is 0, f1 is -1, and f2 is 8. Now let's draw the number line. Number line should be from the beginning, -2, all the way to the end 2. And then in between them we have -1, 0, and 1. We need to study the sign in between these points. So by taking any point here, you can decide, for example, -1.5. We need to study the derivative. So remember, the derivative is 4x cubed minus 4x. We need to study only the sign. Taking a point here, we might take f prime of -1.5. Substitute here. And we are looking only at the sign. So by doing this, we will notice that the sign here is negative. And then we will continue. So we are not going to need this anymore. So we can try now taking a point in between -1 and 0. You might take f prime of 0.5, negative 0.5, and substitute. Again, we don't care about the exact value. We need only the sign, and it's going to be positive. And then you can do the same with a point in between 0 and 1. You can try f prime of 0.5. Substitute it, and you will get a negative answer. And then you will try any point between 1 and 2. You can try f prime of 1.5. Substitute it in the function, and you will get a positive answer. Now, after this, you are going to try to check these signs. So basically, negative means that the slope, the tangent was going down. So the slope is negative. Positive means it goes up, and then down, and then up. So by doing this, we will notice that this was up, up, up. So these points, this one, and this one, are maximum values. Now we need to tell which one of them is absolute. Now, the one that has a bigger number, f of it is a big number, then that's going to be an absolute. So by doing this, we notice that these two are bigger than 0. So at 0, we have a local minimum, a maximum. Where at these 2 points, they are equal, so we have an absolute maximum. So we can say we have an absolute maximum at -2 and 8 and 2 and 8, where we have a local max at 0, 0. Now let's look at the minimum. Now this point is down and this point is down. So this and this are minimum, and since they are equal, then they are absolute, because there's nothing lower than these 2 points. So absolute minimum at -1 and 1, -1 and -1, and 1 and -1. So 2 absolute minimum. We are going to do the same thing with this question here. So first of all, we will find the derivative. Make it equal to 0. You can divide everything by 6. So you have x equal 2 or x equal -1. We need to check whether these points are within the interval. We will notice that this is between 0 and 3, but this is not. So this is not a critical point. Okay, it's not a critical point. So we have only one critical point. Now we need to find f0, f2 as a critical point, and f3. So f0, you will substitute 0 here, and you will get 5. f2, you will substitute 2 in this equation, and you will get -15. And you will use f3, the endpoint, and you will substitute, and you will get -4. Now we're going to create the number line between between 0 and 3, and I just have 2 here. Taking any point here, substitute it in the derivative. Remember, we are substituting in the derivative because we want to see the direction of the tangent. Take any point here. Maybe you can take f prime of 1. It's going to be 6. 1 squared minus 6 times 1. The answer is -12. So it is negative. Okay. Then we will take a point between 2 and 3. You can take f prime of 2.5 and substitute it. You are going to get a positive answer. Now we need to decide whether they are maximum, minimum, absolute, or local. Minus means the function goes down and then it goes up. So what happened? One minimum. That's going to be my absolute minimum. So I have a minimum here. That's an absolute minimum at 2, -15. Now these two are max. Let's compare between this one and this one. This one is bigger than this one, so this is going to be an absolute, this is local. So we're going to say absolute max at 0, 5, local max at 3, negative 4. Okay, doing the same with this question here, we're going to find the derivative. Derivative of the function will be negative 2x over 2 square root of 9 minus x squared. These two will cross out each other. And then we will make it equal to 0. So x over square root of 9 minus x squared equal to 0. You cross multiply, so x will be equal to 0. That's going to be my critical point, and it belongs to the negative 3 and 1 interval. Now I'm going to say, what is f negative 3, what is f0, and what is f1? By substituting in the equation here, we'll see that the f negative 3 is going to be 0, this is going to be 3, this is going to be square root of 8. And then you draw the number line from negative 3 to 1, and that's 0 here. Study a sign here and here. Okay, so by substituting in the derivative function, which is negative x over square root of 9 minus x squared, that's the derivative. So we can take f prime, let's say, of negative 1 and f prime of 0.5. By doing this, we will substitute negative 1 here and 0.5. We are going to get positive and negative answer. Now, if it is positive, then the function was growing and it goes down. So this one is maximum point, so we know, and it's the only maximum. So we know that the absolute maximum at 0.3. Now these two are minimum. Now we will compare between them. Which one is smaller? This one is smaller than this one. So we have absolute minimum at negative 3 and 0. And we do have a local minimum at 1 comma square root of 8. Now in this question we are going to follow the same thing, so I need to find f prime of x, and basically we can take u equal x, u prime is 1, v equal x squared plus 1 over 5, v prime equal 2x. So will be u prime v minus u v prime over v squared. In a simplest form, f prime of x will be equal to 1 over 5 minus x squared over x squared plus 1 over 5 to the power of 2. Make it equal to 0. That's going to cross here. So it will be 1 over 5 minus x squared equal to 0. 1 over 5 equal x squared. Taking a square root of both sides, x will be positive or negative, a square root 1 over square root of 5, or you can call it a square root of 5 over 5, positive and negative. Just to check whether these positive square root of 5 over 5 are in the interval. Yes, it is within the interval, so both of them are critical points. Now I need to find f of negative 1, the end point, and that's going to be negative 5 over 6. Then f negative 1 over square root of 5, substitute, it will be negative square root of 5 over 2. Then f 1 over square root of 5, and it's going to be a square root of 5 over 2. And finally f2, and it's going to be, now if I will give you a decimal for these, just rounding to make it easy for you to get the idea, that's going to be negative 1.12, going to be 1.12, and this is going to be about 0.48. Now we can draw the line. We have negative 1, we have 2, I have these 2 points, which is negative 1 over square root of 5 and 1 over square root of 5. Remember that we are going to choose points here, here, and here, substitute in the derivative, not the original function. If you do that, you will get negative positive, and negative. So what does that mean? Down, up, and down. This point here, minimum, maximum, maximum, and minimum. So I have two minimum, two maximum. I need to tell which one is absolute, which one is local. So between the maximum first, so this point is max, this point is maximum, and this point here is maximum. Which one is greater? This one is greater, so I have a absolute max at 1 over square root of 5 comma whatever the answer, square root of 5 over 2. That's absolute. Now we have local max at negative 1 comma negative 5 over 6. Now we will talk about the minimum here. We have this is minimum and this is minimum. This one is smaller, so this one is going to be the absolute. So I have absolute minimum at negative square root of 5 over 2 comma negative 1 over square root of 5 comma negative square root of 5 over 2, and local minimum at 2 and whatever answer here, 0.48. That's everything for today's lesson. Please let me know if you have any question, and see you next video. Bye bye.